Good day, sir. I am Brent Mark DECASA, BC2 Betelgeuse, and this is my formative assessment. Damage and defects most commonly encountered due to loading and unloading operation and severe weather condition. Causes of bulk carrier hull damage and failure in operation. As you can see in the picture, there is a damage in the ship's hull or damage to side shell, externally through contact with dock sides or tugs, and internally from impact by cargo dislodging equipment during discharge. Can result in initiating fractures and or fatigue of the structure. In single-side skin, bulk carriers, bulkheads, trunks, and ballast tank boundaries can present hard spots that concentrate forces where the change in construction occurs. For example, longitudinal to transverse framing. This may lead to undetected fractures. Internal degrading through corrosion may be accelerated through chemical action from certain cargoes. Walls in particular may be subject to grooving or corrosion, in which the material forming the weld corrodes at a faster rate than the plating to which it is attached. Fatigue failure may result due to loss of cross-sectional area in the plating joints. Bulk carrier encountering bad weather at sea. A ship loaded a full cargo of aluminum hydroxide in Australia for discharge in the USA. The ship was equipped with box holds, which allowed for easier cleaning and inspection before loading. At the discharge port, at the same time as the ship was being unloaded, seawater ballast was being taken on board. It was later found during the discharge that 500 tons of the cargo was water damaged by the ballast, which was confirmed to come from a hole measuring 100 mm times 20 mm in the hold or ballast tank sail plating. The hole was most likely to have been caused by steel door grab damage in the discharge port. In ballast holds, sloshing forces due to partially filled spaces, such as may occur when changing ballast for environmental reasons, may result in damage to the structure. This damage may go unnoticed if it is in an inaccessible position. Lashing is also a known cause of secondary damage after a space has become flooded. Damage to bow plating such as is possible through impacts associated with swinging or loosely stowed anchors may cause an initiating fracture or fatigue in bow shell plating that could lead to failure and then subsequently flooding. Internal integrity of forward spaces that are usually used for ballast and or stores is therefore of vital importance. Corrosion degradation will seriously reduce the ability of plating and stiffening to withstand the forces of which it will be subjected. In larger ships, partially filled force-feed tanks may set up destructive slushing forces unless the tank structure is designed for this. External forces, horizontal and or vertical, may cause hatch cover dislodgement. The cargo hatchway, if it loses its protection in this way, is a major access for water ingress and a serious threat to the integrity of the hull. When a vessel requires repairs to damaged equipment or to the hull, it is necessary for the work to be carried out to the satisfaction of the classification society surveyors. In order that the ship maintains its class, approval of the repairs undertaken must be obtained from the surveyors either at the time of the repair or at the earliest opportunity. Finally, a few other areas on board susceptible to defects and damage that must be frequently examined. Ballast tanks that are bordering the hot engine room spaces. Ballast and void tanks neighboring the heated fuel, oil, and cargo tanks. Next, tanks that are in the vicinity to areas where vibration levels are high. Side shelf spaces between the loaded and light drafts. Tanks adjacent to external tug contact points. Spaces in the forward part of the vessel, especially to be considered after heavy weather. That is all, sir. Thank you.